So for 2 to the x, when x is 0, 1, 2, 3, 4, 2 to the 0 is 1, 2 to the 1 is 2, 2 squared is 4, 2 cubed is 8, and so each time you're multiplying by 2. So 0 is 1, 1 is 2, 2 is 4, 3 is 8. So we talked about having a horizontal asymptote at the x-axis. So the graph starts here and goes up. It doesn't cross there. It just kind of goes along the x-axis and then shoots up. And so the domain, if it's all the way out here, negative infinity, and it goes all the way to the right to positive infinity, that's all real numbers. Then it comes off of the horizontal, or the horizontal asymptote, which is y equals 0, and it's above, and so the range would be y is greater than 0. So if I have the function 2 times 2 to the x plus 1, I'm going to start my table at negative 1, 0, 1, and 2 and 3. And so if I have 2 to the negative 1, that's 1 half. So 2 times 1 half is 1. 1 plus 1 is 2. Then if I put a 0 in here, that's 2 to the 0 is 1. 2 times 1 is 2, plus 1 is 3. And so I'm using the table from number 1 to generate my values. I already know that 2 to the x is 2, 4, and 8. So for 1, it's 2. So 2 times 2 plus 1 is 5. And then when 2 to the x is 2, that's 4. So 2 times 4 is 8, plus 1 is 9. And then 3 gives me 8. So 2 times 8 is 24, plus 1 is 25. So the domain is always all real numbers. And then we mentioned that if we have a number here, that tells us our HA. And all these numbers are bigger than 1, so my range would be y is greater than 1. So I have a horizontal asymptote at y equals 1. Then I have points at negative 1, 2, 0, 3, 1, 5, 2, 9, and then 325 is way off. So then this one, that is my HA. to start my table at -3. And so if I put in -3 for x, that would make my exponent be 0. So -2 to the 0 is -1, minus 5 would be -6. Which you could just put this in the calculator and find a table. But -2 would be -7, -1 would be -9, 0 is -13, and so 1 would be -16, -21. And so all of these numbers are less than -5, so my range is y is less than -5. So -3 is at -6, -2 is at -7, -1 is down here at -9. So we can't really see much of that graph since the asymptote was so low. Then I have two problems where it's asking me to find the equation given some transformations. So we need to review our transformations. So when I have negative f of x, that is a reflection across the x-axis, which is the main reflection we deal with in this class. We just usually just shorten it to say it's a reflection. And then if I have f of x plus h, where I'm adding inside where x is, that is going left. And then if I'm subtracting inside with x, that's going right. And then if I'm adding on the outside away from x, that's dealing with my y values. So if I add, that's going up. If I subtract, it's going down. Then when I multiply my function by a number that's bigger than 1, that is a vertical stretch. That's saying my y values are... the change in my y value is increasing by some factor, a. And then if my a is between 0 and 1, that is a vertical compression. So if I'm shifting to the left, I'm going to add x plus 1. And it tells me my parent function's 2 to the x, so I have 2 to the x plus 1. Then going down, I'm going to subtract 7, and then a compression. I'm going to multiply by 0.5. So y equals 0.5 times 2 to the x plus 1 minus 7. And then the next one, still my parent function, is 2 to the x. I'm going to reflect across the x-axis, that's negative 2 to the x. And I left some room because it's a stretch by a factor of 5. So I'm really going to multiply by -5, so 2 to the x, and then it's going to shift up 3. So I have -5 times 2 to the x plus 3. So the next one, I have a horizontal asymptote at y equals -3. So that tells me that my graph shifted down 3. And then I'm going to look at these points that were given. So we know the parent function has points at 0, 1, 1, 2, 2, 4, 3, 8, and 4, 16. So I'm going to look at my first 2 points. We know that the y went down 3. 1 minus negative 2 is 3. And then from 0 to 3, it had to have gone right 3. And then to see if there's a vertical stretch or compression, I'm going to look at the change in the y values. So here, that's increasing by 1, increasing by 2, and increasing by 4, in which my parent function is increasing by 1, by 2, by 4. So they're the same change. There's no stretch or compression. And so I just have these 2 transformations to look at. I went down 3 and right 3. So my equation would be y equals 2x minus 3 minus 3. So this one, I have my horizontal asymptote at 5. And my graph is below that, and so there's a reflection. And since it was at 5 and not 0, there is a shift up 5. Let me look at some points. It's at negative 2, and that's negative 1. 0 and positive 1. And so I can look at the change and see that there is also a reflection since the changes are negative, but there was no stretch or compression. And so it should have started at 0, but it started at negative 2, and so that went left 2, and then went up 5. And there's a reflection. So y equals negative 2 to the x plus 2 left, and then plus 5, because it went up.